This is my compression molding project for ETM 2080. For the first part that was produced, we have the shot glass. The raw material used was phenolic. The quantity was 2.5 ounces. The way that we measured the amount of phenolic used was a measuring cup. The temperature used to heat this phenolic was 225 degrees Fahrenheit. The pressure was 4,000 psi. The processing times are listed to the left for 1,000 and 120 seconds to complete this part. As you can see from the pictures to the right, the part did not come out very good. There is no bottom. There are chips in it. The edges aren't smooth. The mold material used was aluminum. The mold condition was poor. The machines and equipment are listed to the left, and the defects include that the part as a whole stuck to the mold, and it had to be reheated and heated up 3 times, if I remember accurately. As you can see also, there are some chipped edges on the part. The bottom's gone, and there are scratches on the inside. This could have been from the poor mold, actually. For the second part that was produced in the videos, I called it the ashtray. The raw materials used for this part were phenolic. The quantity was 3 ounces. Again, this quantity was measured by a measuring cup. The temperature again was 225 degrees. Pressure was 4,000 psi. The processing times are listed to the left for 130 seconds. This part was produced very, very quickly. As you can see in this part, the texture is very gritty. As you can see to the right, it almost looks like a bunch of pebbles just pushed together. That's not the desired texture, obviously. There is also discoloration in the middle of the ashtray. The red is kind of lighter than around the other whole part. This isn't desired in any part that you were trying to sell or use. And you can also see the poor edges, which isn't really a defect because you could really just cut out those edges if you really needed to. And also there is a hole on the right side of the ashtray. The mold material used was aluminum. This mold was actually in a pretty good condition, and the machines and equipment are listed to the left. For the third part that was produced, it was an NFL hexagon. I actually would have liked to make this. The raw material used was phenolic. The quantity was 2 ounces. This quantity was acquired by using a measuring cup. The temperature again was 225 degrees at a pressure of 4,000 psi. The processing times are listed to the left for a total of 450 seconds. The mold material used for this part was aluminum. The mold condition was pretty good. The machines and equipment are listed to the left. The defects, I'm really nitpicking if I go into any defects on this part. Pretty much the part was pretty good. The edges look pretty good. They're well trimmed. There is a chip on the top part of the NFL hexagon though, which is a defect for sure, and the edges are poor. But you can trim those, like I said before, with the last part. So, a couple things that would ensure a good part while using the compression molding process would be things like using only 2 ounces of phenolic. So during the course of the video, the only part that really came out great was the NFL hexagon. For that part, you used 2 ounces of phenolic. It wasn't too much, it wasn't too little. It was perfect. So that seems to be a pretty good use of phenolic right there. Another thing that would ensure a good part is letting the part absorb heat and pressure for a defined time, preferably 60 seconds. Just like I said before, the third part, the NFL hexagon, came out great, and it was able to heat for 60 seconds. Also, preheating the mold before using would ensure the part is good because the mold would already be heated, so the phenolic is already taken to the mold and heating up and going through the chemical process already. Not hitting the pen on the mill mold so hard would also ensure a good part. This would ensure that you would keep the bottom in your parts. And not scraping away any excess while in a continuous compression molding machine, because the excess needed on the parting line is kind of necessary, and you can always trim away any excess. Some tests that we could run on some variables that we interact with during this process would be things like a cooling test. And for the cooling test, we would test if letting the part cool down after being heated and pressurized would ensure a better part, letting it sit in the mold for a second. And if this was the case, then how long would be the optimum amount of cooling time? In my personal opinion, I don't think this would actually help the part because, as a matter of fact, the process is very fast, as seen in the current video. Another test that I think that maybe could help benefit would be a scraping test. For the scraping test, we could test if actually scraping away the material while it's being pressurized and heated helps or hurts the part. In my personal opinion, I think that it would hurt the part because the excess is kind of unneeded on the parting line, and the excess can always be trimmed away. This next test is a test that I really think is needed because the current charts aren't up to date, and that would be the phenolic test. And for the phenolic test, you would test each mold and see how much phenolic is exactly needed. The current charts and tables are wrong, and 2 ounces seem to work best for the NFL hexagonal. And another test that could be run is the mold release test. You could run tests on different mold release sprays and if they could help or hurt the part, because prying is timely and can cause damage to the parts, like chipping them, as seen in the NFL hexagon. And a final test that you could run is a level test. And during this test, you could test if the phenolic should be level in the mold, and if this level affects the mold at all. And this would help ensure that the part is even throughout. For some processes that I believe should be implemented, first off, I think that a new shot glass mold should be bought or made. That could save you money. The current one is really torn up from previous students scraping the surface of them with the metal priors. Another procedure that I believe should be implemented is preheating all molds before using, preferably 200 degrees Fahrenheit as seen in the video. The ashtray and the NFL hexagon came out very nice texturally. Another process that I believe should be implemented is that you should burp the part every time. Like I said before, the ashtray and the NFL hexagon, they came out nice. Both parts were burped, and this release of air is needed for the part to shrink, expand to the desired form. Also, I think a procedure that should be implemented is putting a pin on the female mold part. It's on the male part. It's the little pin that you can hit with the hammer, and it would loosen your part up to jiggle it out a little easier. And it works well in most cases. And if the part were ever to get stuck on the female mold, this would be an easy fix because you would just use the hammer, hit the pin, jiggle it off, and there you go. Some things that I found wrong with the process. First off, at the beginning of the video, you said that the chart was in some back of some cabinet. I think that is kind of absurd. The chart shouldn't be that hard to find. It should be in clear sight where any student or teacher could find it. Another thing that I did not like with this process was that there are handwritten notes on lab documents. For something as important as how much material you're using, especially in a business setting, you can't really make people confused like that. So this just should not be happening at all. Another thing that was wrong with this process was using the hammer to try and retrieve the part and jiggle it loose. And in the instructions, it explicitly says not to use the hammer. And lastly, the NFL hexagon mold had not been inspected. This could have been the reason for the design on the bottom of the part. I don't know. I actually liked that design. It looked pretty cool. But I just thought it was worth noting that it was the only mold that hadn't really been inspected, but at the same time, the NFL hexagon is the only mold that had a really detailed and different bottom.